Hey y'all, welcome to today's asynchronous video. In this video, we're going to be looking at how to find an equation from a word problem and how to create a table from that equation to graph onto our coordinate grid. So in this case, our word problem tells me that Thomas calls Yellow Cab taxi company to pick him up from his house to take him to the airport. When the cab arrives, the driver tells Thomas that there is an initial fee of $3 and then an additional charge of $2 per mile until they reach their destination. So we are asked to graph the relationship of cost to miles driven. So first thing we do is I'm wanting to label my x and y axes, first with an x and a y, and second with the units each axis is going to be responsible for. So the way that we can find that is a couple of different ways. One is in this last statement, the relationship of cost to miles driven. In this case, it's telling me that cost is dependent on the miles that I drive. And the other would be in my statement, $2 per mile. Again, telling me that whatever amount I have is dependent on the miles that I drive. So what this tells me is that miles is an independent variable, aka miles is my x variable. Again, x is going to be independent. And so that means my y-axis is going to be the cost or the amount of money that I am spending. So I'm just going to write a little dollar sign right there. So again, I just labeled each of my axes, so it's a little bit easier for me to know what to do with this information as I'm going through. Again, rereading, the cab arrives and the driver tells Thomas that there is an initial fee of $3. This initial fee is what I'm starting out with, meaning the first thing that I'm going to pay is that $3. We can also think about whenever we hear the word initial as the start to our graph. Remember, most times when we have proportional relationships, we start at the point 0, 0. But if we have some information that we need to work with, if we have driven 0 miles and we still have to pay these $3, that is going to be the same as saying this is my y-intercept. So that means on my y-axis, I'm going to start at the point 0, 0 and count up 1, 2, 3 spots to this point right here, because that tells me when I drive 0 miles, I still have to pay $3. So now I can start filling out everything else. I know I'm going to need a y, my equal sign, and my x, but now I got to figure out what my m is going to be. Looking into my word problem, there aren't many other options for what it could be. But I will say our big tip-off that this too is probably going to be my slope is the fact that it has this per next to it. Whenever we see per, I want you to think about slope. Because again, per or slope tells me how something moves, and per gives me those units that it is using to move. So this tells me that my cost changes $2 for every mile that I drive. So that means 2 is what is going to be changing along with my miles, aka my independent variable. It's also going to help me understand the cost at the end. Since 3 is an initial fee, and it happens regardless if we drive any miles or not, 2 is what we're going to use for our slope because it has this word per, and because it helps me understand a little bit more about how my graph grows. So now I'm going to go ahead and make a quick little table, starting out with 0, 1, and 2. So I already know for my x equaling 0, it's going to give me a 3 as an output. I can see that on my graph already, and since this is my y-intercept, because it is my b, I can plug it into my table first and foremost. Then, again, using either substitution or by counting in my table, I know that when this changes by 1 mile, this side should change by $2. So that means I'm going to plus 2 to this 3, giving me the 0.15. Again, telling me that I'm going to go over 1 and up 1, 2, 3, 4, 5. Putting my point right there. And I can do that same strategy again because my ratio is the same. Again, I'm just going up 1, and that means I can go up 2 in my y, giving me a 7 there. So that means I'm going over 1, up 1, 2, putting my next dot here at the point 2, comma 7. So at this point, I have enough information to graph a line for my problem. So I'm going to go ahead and do that, starting at 0, comma 3, going up through my first 2 points, and trying to keep it as straight as I can, and then putting a little arrow at the end. So this is my graph that shows the relationship of cost, again shown here by my dollar signs, to miles driven. So the more miles that I drive, the higher my cost goes, and this is what we should be expecting in problems like this. So I want y'all to go ahead and continue on. As always, if you have any questions, please let me know. Otherwise, I'll see y'all soon.